Warm greetings. Welcome to Swayam Online Learning Portal. I am Dr. S. Ishwari, Head of the Department of Geography, Madras Christian College. In the previous lecture, we have discussed about atmospheric heat budget. So, in this lecture, we will be discussing about the latitudinal heat balance. So, what is the difference between the atmospheric heat budget and the latitudinal heat balance? The atmospheric heat budget is the balance between the atmospheric incoming solar radiation and terrestrial outgoing radiation, that is infrared rays and terrestrial rays. So, in this latitudinal heat balance, we will be discussing about what is the balance between the entire earth surface, entire globe, either it may be latitudes or it may be longitudes. So, this will be discussed in this lecture. The contents we are going to discuss in this lecture are the balance between the incoming solar radiation and outgoing terrestrial heat, the heat surplus in tropics and heat deficit towards the pole, and what are the various that is the difference between the latitudes due to angle, sun's angle and day length, and what force are driving, that is global wind or ocean currents and climate zones, how we are maintaining the earth's overall energy equilibrium. So, these are all the contents we are going to discuss in this lecture. First and foremost is latitudinal heat budget, that is heat balance. That is the amount of insolation received varies from latitude to latitude. So, we all know that from the sun the rays is equally distributed? No, it is not equally distributed, it is varied in each and every latitudes. So, the sun's rays which is received in the equatorial or torrid zone differs from the polar regions. So, this difference we will be studying in this latitudinal heat balance, and the balance heat gained and lost across the latitude. What is the gain, what is the surplus and what is the deficit, that will be discussed here in the latitudinal heat balance. And the region within the equator and 40° north and south latitudes, that is from here to here. So, this region. So, especially this region the sun's heat is gained. So, this is the region of surplus. So, this is the region of surplus, the energy surplus region. And from the 40° north to 40° south latitudes, that region is approximately you will be having this region, and the down the south pole this region. This region is energy deficit region. So, these two imbalances are there in the latitudes. This is significant to control the global climate and climate zone. So, this is the most important factor which control this. This is because of what is the most important triggering factor? The triggering factor is slant sunlight and high albedo of polar region. So, we know that the sun rays is direct here in the torrid zone till 40° north and south, and it is oblique here in the polar region. So, this is the major cause for this latitudinal difference of heat, and it drives the atmospheric and oceanic circulation. So, because of this imbalance in heat, which is the main cause for what? The oceanic circulation, ocean currents. It is also foundation for global energy balance. So, the global energy balance is also supported by this latitudinal heat balance. Okay, you can wonder that the sun's rays is direct in the equator, then why equator is not so hot? It is because the equator, even though receives the highest solar radiation, what it is doing? Its work is, it is transporting its heat, that is heat, to the other region. From equator, it is transporting the heats towards the mid latitude and the poles. The heat is transferred. So, that is the main cause that equator is not so heat. The atmospheric planetary winds and ocean currents. So, this two major factor, this is the carriers, how this heat is transferred from equator to the poleward. So, this two driving force, these two carriers are the most important tools which transport the heat from equator and it distribute towards the polar region. So, this is the driving force. It transfers the excess heat from the tropics, that is energy surplus region. So, we know that this is the energy surplus region, and where it is transporting towards the pole, that is energy deficit region, This makes the loss of heat in the lower latitudes and gain of heat in the higher latitudes. The latitudinal heat budget, mostly the heat is transferred from place across mid latitude, that is 30 degree to 50 degrees, and hence it is also known as what? This 30 to 50 degree is also known as the zone of mixing, because here you can see the mid latitude cells. So, while we discuss about the various cells, you will be getting a clear idea about each and every cells of our globe, that is earth surface. This mid latitude is a mixing zone, that is the hot air from the equator and the cold wind from the polar region is mixed in which region? This latitudinal, mid latitudinal region. So, this region is also known as a zone of mixing. So, it is because of that hot and warm air, what happened? The stormy weather is associated in this region, that is mid latitudinal region. Thus, there is a transfer of surplus energy from lower latitudes to the deficit zone of higher latitudes. So, that transfer, exchange is happening because of this processes, because of air, ocean current, and where it is mixing? It is mixing in the mid latitudes, which maintains the overall temperature balance. If there is no such process happening, what happens? Excess heat in one region and deficit in another region, and it is not feasible for the biolife in all over the earth's surface. So, it will be restricted to the particular place in the earth's surface. So, this temperature balance over the earth's surface is must needed. Heat budget is the balance between incoming solar and outgoing terrestrial radiation. So, you have here the diagram, that is incoming energy gain in the side and outgoing energy loss inside. So, one region getting surplus and another region getting deficit, that is this region is surplus, both the sides, this region till this region is surplus and this region is deficit region. So, there is a transfer of the heat. So, this transfer of heat from lower latitude to higher latitude towards the lower latitude, which generates the balance of temperature. The positive balance causes the heat surplus. If it is going to be a positive balance, heat surplus. So, where there is a positive balance here in the globe, that is here is a positive balance, and if there is a negative balance which leads to heat deficit. So, the polar region is the heat deficit region. So, this is the main concept of heat balance in the latitudes. The balance varies from equator to poles, which we have discussed now. This variation controls the global surface temperature patterns. So, this controls what? The global temperature pattern. How the temperature have been distributed is controlled by this energy exchange. Energy budget components. So, there are so many components are there in the energy balance, that is temperature balance. First one foremost is the incoming short wave radiation. So, incoming solar radiation is one of the most important factor. And the next one is reflected solar radiation, that is albedo. Albedo is that is the reflecting from the surfaces. It will be different from each and every surfaces. So, that albedo also plays a important role, that is one of the major factor. And observed atmospheric radiation. So, the radiation which is received in the Earth's surface, again it is what? It is absorbed by clouds, dust and aerosols which is present. So, that foreign particles plays a vital role here. So, observed atmospheric radiation is also one of the component, and outgoing long wave radiation. So, the outgoing long wave radiation is one of the component. Next is the heat transfer process occurs because of this absorption, incoming solar radiation, reflection and then outgoing terrestrial radiation. So, these are all the components of energy budget. What are all the factors determining the latitudinal heat balance? We know the components, how this is driven by each and every factor. The factors are the sun's angle of incidence, day length variation, atmospheric composition, cloud cover, surface characteristics. So, these are all the main factors which drive the balance of heat, that is temperature in the latitudes. Sun's angle of incidence. So, sun's angle of incidence, higher the angle at the equator which is received, where there is a more concentration of radiation. So, here there is a most concentration of radiation because of direct solar radiation, and which heats the Earth's surface, a small region, and by the contrast there is a lower angle in the polar region which heats the larger region. So, that the heat which is generated is somewhat minimum compared to the higher angle, and which determines the intensity of heating at different places. So, this rays, angles of sun which heat the different part of the earth in differently. Okay. It also causes the latitudinal temperature gradient. There is a gradient, temperature gradients in each and every place. There is a difference. It also controls the formation of major climatic zonation. That in the climatic season and climates, we have discussed about the major climatic zones. So, how the zones have been evolved? Because of this temperature. So, because of the availability of temperature, that is the climatic zones varies and vegetation pattern varies. So, the sun's angle plays a vital role, one of the important factor. Next is day length variation. So, in the equator, we know that it is equal day and night, 12 hours plus 12 hours, equal day length will be there, and in higher latitudes the long summer days is witnessed and short winter days in polar region. So, here long that is summer days and short winter days. In the longer daylight, if it is going to be a lengthy day, what happens? The receiving of solar radiation will be high because the day length is somewhat maximum. So, receiving of the temperature will also be maximum, and if it is going to be short day length, vice versa. The seasonal extremes increases the imbalance. Because of seasons, what happen? Imbalance. So, the example is summer, that is intensification of heat due to day length is long. Winter, what happens? The day length is short. So, that difference you can see here. This plays a vital role in the latitudinal heat balance. The atmospheric path length. What is meant by atmospheric path length? At the equator, the sunlight travels the shorter path. So, here in the atmosphere, it is a very short path. It travels in a short path, and in the polar region, it travels a long path. So, in the earth, this is a short compared to this one. So, this is explained here, and the greater energy loss occurs in the higher latitudes. That is, greater energy loss is higher in the higher latitude, that is in the polar region. The heating efficiencies decrease towards the pole because the incoming solar radiation is minimum. So, then how it can generate maximum heat? So, that is the main concept which is explained. This is a major reason for strong polar cooling. So, polar region is cool because of this reason, that is atmospheric path length. It is long. So, the major reason of strong polar cooling happens in the polar region. Albedo differences. So, we know that the snow and ice at the polar region have high albedo, and here that is 80 to 90%. Comparatively, the forest and ocean have, the forest region has the moderate or medium albedo effect, that is reflection 10 to 40%, and if it is going to be the ocean, it is very low, that is 5 to 10% reflectivity will be there. So, low albedo effect will be there. So, this variation in the surface reflectivity increases the heat contrast, that is the heat which is reflected here will be more and the heat which will be reflected here will be less. The seasonal snow covers rises the albedo more in solar radiation. The seasonal snow covers which affects the albedo effect also. The polar regions experiences the intensified cooling. So, we know that polar regions means it is a cold region. So, this is mainly because of this albedo effect, the reflectivity effect. Next is the latitudinal insolation curve. So, we have discussed this one earlier, that is the insolation will be high in the equator, insolation will be high in the equator, and it has the sharp bend here, and drastically it will be low towards the pole. So, this uneven heating drives what? The distribution of climate zones, and it also strongly influences global temperature pattern. So, global temperature pattern is derived because of this insolation, incoming solar radiation. Next is heat surplus in tropics. So, the tropical region, the heat is surplus. So, how? That is high solar angle in the tropical region, which ensures the intense solar heating. Because of heating only there is a gaining, that is a surplus, and the dense atmosphere absorbs and redistribute heat efficiently. So, how it redistribute efficiently? Because the presence of clouds, the clouds absorb the heat energy, it retains with it, and then which gives the warmer effect in the night time. So, that you have to remember, which we have discussed earlier lectures. The low albedo is due to the ocean dominance and increase the absorption. The seasonal temperature variation is minimal in the tropics. We know that it is minimal in the tropics and it is maximum in the polar region. The region experiences this one net gain heat throughout the year. So, this is the catch of this lecture, that is this region, that is a tropical region, the tropics is the net gain of heat throughout the year. Heat deficit in poles, that is the solar, it's opposite to that, it is in the solar radiation will be weak due to low angle of sun, and then high albedo causes what? The greater reflection of the solar energy. The sunlight which travels in the longer path, meantime it heats the larger area. So, because of that the heating process is reduced, that is reducing heating. The strong radiational heat losses occurs from the surface. There will be a strong radiational heat loss. So, this region experience, this is the most important here, that is net energy deficit. So, poles deficit, tropics surplus. The energy balance line. So, this is most important latitudinal line, that is 38° latitude. So, this latitudinal line is known as energy balance line. The incoming solar radiation equals the outgoing terrestrial radiation. So, if there is income, there should be a expenditure. The same way it should be equal, that is known as balance. So, where the balance created in this 38° latitude, the balance is created. The marks the boundary, this is the boundary, the 38° is the boundary between the heat surplus and heat deficit region. It acts as a border, it acts as a mediator. Heat transfer from the equator towards mid latitude begins in this latitude. From this latitude only the heat transfer is process is started. The major atmospheric circulation cell interact in this zone. In this zone only the major atmospheric circulation cells have been activated. So, this one you will be elaborately discussed in that is the polar atmospheric circulation cells. In that concept we will be having an elaborate discussion on this. The climatic transitions and contrast are strongest in this region. So, this 38° latitude is the most important latitudinal line or border which balances the surplus and deficit. Seasonal shift of balance line. This balance line is not a constant one. It will be shifting seasonally. How it shifts? That is the zone of shifting northward in the northern hemisphere during what? The summer season. It will be shifting in the northern side. So, it will be shifting in the northern side, and southward shift will be there in the southern hemisphere in the summer. Okay. So, the shift of this 38° line, latitudinal line will be there in northern and southern hemisphere both in summers. The seasonal movement strongly influence the monsoon circulation. So, seasonal wind, here also seasonal shift. Because of seasonal shift, there is a seasonal that is wind, that is monsoon. The storm track shifts along with this zone. Because of the shift, what happened? The storm track also shifted. The heat transport patterns are modified seasonally because of this shift during summer in northern and southern hemisphere. Global heat budget. So, that is the heat surplus occurs in 0° to 30° latitudes due to high insolation, incoming solar radiation. The heat balance is nearly neutral around, that is 35° to 40° latitudes. There it is somewhat neutral state. Heat deficit dominates in 40° to 90° latitudes. It is towards the poles. So, this is the characteristics of the latitudes. This imbalance is essential. Is it essential or not? Yes, it is essential. It is essential for what? That is global atmospheric circulation. So, we have the global atmospheric circulation, how the air or wind have been transferring from one latitude to another latitude. So, what is the effect of it? That is mainly due to this global heat imbalance. This leads to the formation of major global pressure belts. So, in the globe we have various pressure belts. So, that pressure belts is created because of this imbalance. The need for heat redistribution. So, how the heat is redistributed? The heat which is gained by the equator or torrid zone is not kept by itself. It is distributed to the other place where there is deficit. So, that the excess heat at the equator is transported towards the pole side, that is poleward because of deficit. This transfer prevents overheating in the tropical region. If it is going to keep the heat with itself, the tropical region, it will be very hot. So, what happened? That excess thing to be diverted towards the polar region, so that it will be somewhat mild comparatively. It also reduces the extreme cooling at the poles. So, if this heat is not transferred to the pole, what happens? Here it will be extreme cold, here it will be extreme hot. So, this exchange is most important. The process maintains the Earth's overall thermal balance. So, in such a way the thermal balance is maintained in the global pattern. It drives the global atmospheric and oceanic circulation. So, because of this process, the main concept, that is global atmospheric and then oceanic circulation happens throughout the Earth's surface, entire globe. The role of atmospheric circulation. So, we have discussed about atmospheric circulation. So, what is the role of it? That is, the atmosphere circulates through Hadley, Ferrel and polar cell. So, you have here Hadley cell, Ferrel cell, polar cell. So, these cells have transferring the heat energy from, that is equator, towards the polar region. So, this heat transfer is happened in these cells. These cells transfer the heat both not only vertically but also horizontally. the warm air moves poleward. So, warm air is moving from equator towards the pole in the that is from the low latitude towards the higher latitude. So, this is the higher latitude, this is the lower latitude. The cold air flows equatorward. So, here from here the cold that is air is flowing from higher latitude towards the lower latitudes. So, this vice versa happening in the latitudes. The cold air that is this circulation controls the formation of global wind belt. So, because of this the global wind belt have been created. So, this atmospheric circulation plays a important role in the transferring of temperature. Hadley cell. So, we have in the previous diagram we have discussed about Hadley cell. So, this region. So, here the Hadley cell is the strongest atmospheric circulation cell. So, why it is strongest? Because it is nearby the equator, that is the torrid zone, it covers the torrid zone. The warm air rises near the equator due to the intense heating. Here there is an intense heating, because of that what? Because of intense heat the air begins to rise from the equator. Then the air descends in the subtropics and creating a dry high pressure zone. So, from here what happens? The air is descending towards the equator. The transport of large amount of latent heat poleward. So, because of this the transport of latent heat, the latent heat concept we will be discussing in detail in next lectures to come. This circulation strongly controls the tropical and subtropical climates. So, this latitudes the climate pattern is mainly controlled by this movement of air. Ferrel's cell. So, the next cell is Ferrel's cell, that is it operates in the mid latitude. So, mid latitude the latitude of mixing. So, where there is a warm and cold air masses meet. So, that cell is Ferrel's cell. The warm subtropical air moves poleward. So, here see the warm subtropical air moves poleward and the cold polar air flows equatorward. So, here see you can see the arrow marks, it is moving towards the equator. This circulation generates the prevailing westerly wind. Because of this exchange of air, this westerly wind is generated here in this mid latitudes. It helps the redistribute and balance heat in the mid latitudinal region. Because of this there is a balancing heat in the mid latitudes. The next one is the polar cell. So, the topmost the polar region, it is the weakest atmospheric circulation cell. Air flows equatorward towards the subpolar latitudes. The air flows equatorward towards subpolar latitudes. So, where that is equator to subpolar the air is flowing. It also reinforces a very cold polar climatic condition. So, the very cold climatic condition is because of this transfer of temperature, that is air masses. The cold and dense air sinks over the polar region. So, we know cold air will be heavy, because of the heaviness it sinks. Ocean currents. The ocean currents, ocean gyres transport the warm water poleward and from low latitudes. From low latitudes the warm currents have been raised towards the polarwards. That is the cold water flows equatorwards. So, from here the cold currents will be flowing towards equator latitude, that is lower latitudes. So, these movement moderates, that is warm moving up, cold moving down. So, these exchange of air masses movement, what is the effect of it? The moderate regional and global climate, it moderates it. The gyres are driven by prevailing winds and Coriolis force. Because of Coriolis force and then prevailing winds, this movement happens. It redistribute the surplus heat across the oceans, that is the surplus heat is redistributed because of this process. Surface characteristics, that is land heats fast than the water. So, and then the ocean, what happens? The large amount of heat, it releases the heat slowly. The ice and snow have the reflectivity, that is albedo effect, and the vegetation have lower albedo. So, these are all the surfaces, each and every surface have its different albedo effect. So, that each every different surfaces, land masses and water masses have been discussed here. And urban areas retain the heat and enhances the local temperature. So, there is a regional surface differences in heating and distributing the received heat. So, because of that the effect is differed from various surfaces. Atmospheric composition, that is the atmosphere have greenhouse gases which receives the heat, and the aerosols which scatters the heat radiation which is received, and ozone which absorbs again the heat, and water vapor which affects that is it balances the through the latent heat and then condensation process. So, all these atmospheric components plays an important role in global warming and climate regulations. So, global warming and climate regulations is because of all these atmospheric composition. Earth tilts and season. So, we know that the because of earth tilt what happens, the various season happen, summer, winter, autumn and spring, and then there is a difference in the pressure and wind belts shifts also with the seasons, which in turn influences what, the monsoon circulation, and also it creates the heating imbalances in the increasing towards the higher latitudes. So, if it's one moves from polar region towards the equator side, the heat will be somewhat gained. So, that difference can be seen because of this earth tilt. Rotation and Coriolis effect, we know that the Coriolis effect in the northern hemisphere, it deflects in the right side, and in the southern hemisphere it deflects towards the left side, which is one of the most important force and effect which drives most of the wind circulation, and the deflection influences the direction of heat transport. Because of this, what happened, the direction of heat transport is also differs. It plays a major role in forming the global climatic patterns. So, climatic zones, the main concept of this is the major climatic zones. It controls the direction of trade winds and then westerlies. So, in the previous the cell circulation, the water there is a air mass circulation, we have seen the westerlies, easterlies and trade winds. So, because of this rotation and then Coriolis effect, all these movement happens. Formation of climatic zones. The climatic zones are formed because of this circulation or balance of heat. The earth is divided into how many zones? The tropical zone, temperate and polar zones. These zones form due to heat surplus and heat deficit. So, what the concept heat surplus and heat deficit plays an important role in the classification of climatic zones. The temperature zones strongly influence the natural vegetation because of its mild climate. They also determine the global rainfall pattern. So, because of the feasible condition, the vegetation is also grown here in the temperate region. Together they shapes the overall global climatic system. So, all these combines to form the global climatic zones. The importance of latitude heat balance. So, what is the importance? That is, it influences the formation and movement of weather system. So, day to day happening, hour to hour happening weathers are controlled by what? This latitudinal heat balance. It controls the global distribution of climatic region. So, in the previous lecture, previous slide, we have discussed about the climatic zones. So, its influence is most important. It drives the major wind systems, either it may be a monsoon or it may be a trade wind or it may be a westerlies or easterlies. All these winds have been driven by the latitudinal heat balance. It affects the direction and strength of the ocean currents. So, due to the Coriolis effect and other rotation, so this direction of wind is also diverted based on that. It regulates the Earth's overall temperature balance. So, this is the most important of latitudinal heat balance. To summarize the entire discussion, the latitudinal heat balance refers the balance between the incoming solar radiation and outgoing terrestrial heat. It is a result it's result of what? That is heat surplus in one region, that is tropics, and heat deficit in another region, that is polar region. This balance varies with the latitudes. It is because of sun's angles of incidence, day length and other factors. The unequal distribution of heat drives what? That is global wind system, ocean currents and the formation of climatic zones. It plays a vital role in maintaining overall energy equilibrium. So, I hope you understand this concept. In the upcoming lecture, we will be discussing on horizontal temperature distribution. Thank you.